The last thing we're going to look at in this section is compound interest, which tells us how your money grows based on how many times interest is applied per year on your account. So the formula we're going to focus on, which we will revisit later, for now we just want to recognize what it is and what the variables stand for, is a to the t, or a of t, equals p times the quantity 1 plus r over n to the nt. And n is the number of times your money gets compounded. So we'll say n is the number of compounds per year. For example, if n is equal to 1 in the formula, interest is applied to your account at the end of every year, so it happens yearly. If n is 2, it's semi-annually, so interest will be applied to your account twice a year, meaning at the end of every 6 months. If n is 4, you're looking at quarterly interest, so every 3 months interest is being applied to your account. And if n is equal to 12, interest is being applied to your account monthly, and that's how your money grows. At the end of every month, there's a little bit of interest added to it. You get that new total, and then the next month it grows a little bit more by that interest being applied to it. T is time in years. A of t is the amount sitting in your account at time t. P is the principal, or basically the starting amount, how much you put in the account, let's say if we're talking about a savings account, and R is the interest rate that's given to you yearly. So basically those are the variables to understand, and our main goal for this video is just to be able to know how to deal with plug and chug. We'll look at the numbers in detail in the next section. So let's say you put $1,000 at a 5% yearly interest rate, compounded quarterly. So that's the key word. When you see compound, you think of the big formula, and you think quarterly. In your head should pop up a 4 because every 3 months they're applying the interest. How much money will you have sitting in the account after 3 years? Well, that's after 3 years, that's time. So the initial amount I'm putting in the account is P, and the yearly interest, R, happens to be 5%. And remember, whenever we're dealing with percents and doing math with them, we gotta have them in decimal form. So 5% is 0.05. That tells me the amount must be 1,000 I started with, 1 plus 0.05 over 4 raised to the 4 times t, which is 3. So all I did was I just went into the formula and I plugged in all the knowns that they gave me. So now I got to do the math carefully, not to do any order of operations incorrectly. So 0.05 divided by 4 is going to be 0.0125, and we're going to raise it to 4 times 3, which is 12. So I have 1,000, 1.0125 raised to the 12th. I'm going to do this part first. Whatever number it gives me, multiplied by 1,000. Remember exponents first, so let's do that. And I'm getting 1160 point, let's say 75. Let's do it to the nearest cent. So at the end of 3 years, you have 1,160 and 75 cents sitting in your account. In other words, you started with 1,000, so you made 160 and 75 cents in interest. Now let's have you guys try part B and then come back and check the answer. So hopefully you had a chance to try that. All the components are the same. I'm starting with 1,000 and I have the 5% interest, but the one thing different here is that it's compounded monthly, which means based on what we talked about earlier, n has to be 12 in this case. So we'll divide that by 12. And n, again, t, n is 12, t is 3 in this case. So all I'm doing again is putting in the n, the r, the n, and the t, and the p in the formula. And once we do the simplifying, we get 1,000, 1.0125 raised to the 36, I guess, and we end up with, oops, scratch that, I did the base wrong. I got to divide 0.05 by 12. You could punch it all into your TI at once. I'm just showing the step by step. That's going to be 1 plus like 0.0041 6, 7, let's say. Carry enough digits if you're doing it step by step. Don't truncate it too quickly because you'll have round off error. So a good rule of thumb is to carry like 5 digits at least. I'm doing 6 here just to be safe. And I'm going to get something like 11, 61, 47, let's say. So if you're compounding monthly, meaning applying the interest more often, you're making a little bit more compared to applying interest quarterly. Your money's growing a little bit quicker because at the end of every month, it grows a little bit because it got the interest. Then it grows a little bit more at the end of the next month and so forth, versus in this part A where we looked at interest being applied every 3 months because it was quarterly. So a little bit more if you do it monthly, and if you do it daily, even a little bit more. We'll look at those in the next section.